So today's learning intention is sketching quadratic functions by completing the square. So our National 5 essential skills are factorising again and completing the square. You've seen this before at National 5 level, but I'm going to take it one step further, make it a little bit more complicated and into higher level, but it's still just completing the square. So our prior knowledge is we know that a quadratic function has the form y or f of x equals ax squared plus bx plus c. Now the process of rewriting this equation into a new form, y equals a times x plus p squared plus q, is called completing the square. So we already know that when we have it in the form y equals a times x plus p squared plus q, then that we have completed the square. And once it's in this form, you can easily locate the turning point of the parabola or of the quadratic function and its maximum and minimum value, including functions with no real roots. And that's where it really comes into its own. If you've got a function that has no real roots, then it's really hard to sketch. However, we put it into this form, we can immediately read off the axis of symmetry, x equals minus p. We can read off really quickly its turning point, minus pq, and its max or min value is just the value at q. Okay, it's just whatever the number q is. This is really useful, even if you can factorise it and it does have roots. It's also a really nice way of quickly sketching a quadratic function. Let's do some examples. Example 1. Let's try and sketch the function y equals x squared plus 6x plus 8. So a simple one just to get us going. So I want to put it in the form y equals a times x plus p squared plus q. So let's look at the first bit here, x squared plus 6x. I'm going to use this to get myself started. I want to form x plus p all squared. Now in this example, the coefficient of x squared is 1, so a is 1. There's no common factor here. So I take the 6x, I'm going to divide the coefficient of 6. I'm going to divide that by 2. It's going to give me x plus 3 all squared as my starting point. Now that's in square brackets, and outside I've just left the value plus 8 alone. I've just left it there. Now let's have a think about this x plus 3 squared. If I square out the brackets, x plus 3 all squared, that's going to give me x squared plus 6x plus 9. I want the x squared, okay? I've got the 6x, that's fine, but this number 9's appeared. It's extra. It wasn't in the original part that I've just converted. So I'm going to have to get rid of it. So what I do is I balance out and I just subtract it outside the square brackets. It's going to appear inside that square bracket if I square out x plus 3 squared. It's appeared, I don't want it, so I'm going to then balance it out by subtracting it outside the bracket. So simplified then, I've now got y equals x plus 3 all squared. 8 minus 9 gives me minus 1. And that's me finished. I have now completed the square. I've changed the form of x squared plus 6x plus 8 into a brand new form, x plus 3 all squared minus 1. Now it's always nice at this point just to stop, work backwards, start with your x plus 3 all squared minus 1, multiply it out and simplify, and you should get back to your starting function, x squared plus 6x plus 8. So now I have it in this new form. I'm just good to go for sketching. Axis of symmetry is x equals minus 3. So I've got a plus 3 in the bracket, I change a sign, I get a negative 3. That gives me an axis of symmetry. The turning point, I just read it off. I've got minus 3 and negative 1. The value outside, the q value outside is minus 1. So that's telling me already I've got a minimum turning point and a minimum value of minus 1. A quick sketch is all I need. It's cutting at 8. Where did I get that from? It cuts the y-axis at 8. Well, that's because the original function is x squared plus 6x plus 8. So that value at n plus 8 tells me where it cuts the y-axis. Okay. It's cutting at 2 roots. I've not bothered factorising to find out what they are. I don't really care. It cuts, but it's important I've got the axis of symmetry and the minimum turning point is minus 3 minus 1. If you want to go back, you can go back to x squared plus 6x plus 8, factorise it as normal, and you could find the roots there. It's not always necessary. This is just a sketch. Example 2 then, why don't we sketch the function f of x equals 5x squared plus 20x plus 15. Now, have a number before x squared. We've got a common factor. We're going to have to deal with it now. So I want to put this function into the form a brackets x plus p squared plus q. So I've got an a value now. I've got a common factor of 5. 5 goes into 5 and 5 goes into 20 4 times, remember. So here I take out the common factor. I've got my square brackets. 5 times x squared plus 4x. Close your square brackets, and I've left that 15 lying out there just now. Just leave it alone. So what I want to do is I want to take my 5x squared plus 4x, and I want to kind of complete the square for that part. I look at the coefficient of x is 4, I divide that by 2. That's going to give me 5 times x plus 2 all squared. 15 is just left on its own just now. So let's have a think about this 5 times x plus 2 all squared. If I was to multiply that out, what would I get? Well, x plus 2 squared is going to give me x squared plus 4x plus 4. 5 times that will give me 5x squared plus 20x plus 2. The original function, I've got a 5x squared, that's a big tick. I've got a 20x, that's a big tick. But I've now got this plus 20's appeared. So I'm going to have to balance this out. We take my plus 20 and I'm going to take it out the square bracket and subtract it. That's me balanced that, taking it away. So now I've got f of x equals 5 times x plus 2 all squared, and 15 minus 20 is my minus 5. And that's me completed the square. Again, take a moment to stop. Just double check I've got that right. You would take your 5x plus 2 all squared minus 5, multiply out the brackets, rearrange it, and do you get back to 5x squared plus 20x plus 15? Okay, double check that and you're happy with it. Then I can use this completed the square form and I can sketch my quadratic function. Axis of symmetry is going to be x equals minus 2. Turning point is minus 2 minus 5. So this function is going to cut the y-axis at 15, and it's got a turning point at minus 2 minus 5. It's a minimum turning point. The coefficient of x squared was always positive, it's plus 5, so I have got a minimum turning point. I've got a happy curve. Another example then, right, one step harder. Let's see what can happen. Example 3. Sketch the function y equals 10 plus 3x minus x squared. So it's all back to front now. Right, something mad's going on. Make it simple for yourself then. I always just rewrite it round the right way. Y equals minus x squared plus 3x plus 10. So I've got a negative x squared. I've got a minus 1 negative coefficient of x squared. So what type of curve have I got? I'm going to have a maximum turning point. Okay, A is negative, maximum turning point, sad curve, upside down. Now what am I going to do? Well, take out a common factor, A equals minus 1 for a start. So y equals minus, put my square brackets in, I've got x squared minus 3x, close the bracket, and I've got a plus 10. So I just take out a negative 1 common factor for the first part of the quadratic. Same sets again, take the coefficient of x and half it. Now this is higher, it gets nasty. We are going to have a fraction coming in. So I've got minus square brackets, x minus 3 over 2 all squared plus 10. So if I think about this x minus 3 over 2 all squared, what would happen if I squared out that bracket? Well, what I'm going to have is I'm going to have minus, that's the common factor, so minus, and then I'm going to have to square the minus 3 over 2. That's going to give me minus 9 over 4. Okay, so square the fraction, square the top, 3 squared, square the bottom, 2 squared. That gives me minus 9 over 4. Remember, square negative numbers become positive. So I have to balance that out. Okay, if I was to square out the square bracket, sorry, if I had to organise that, I'd end up with a minus 9 over 4 that I don't want. So I'm going to have to balance that by adding it onto the 10. So I've now got y equals minus, square brackets, x minus 3 all squared, plus 10 plus 9 over 4. Now remember, it's easy to add fractions together, whole numbers and fractions, if you convert that whole number to a fraction where the denominator is 4. That gives me minus x minus 3 over 2 squared plus 40 over 4, that's just 10, plus 9 over 4. Keep going then, I've got minus x minus 3 over 2 all squared plus 49 over 4. Nasty, I know, and I'll go over that in class if you want, but it's just your fraction work needing a bit of revision. I can sketch that now then. I said before it was going to be a maximum turning point because it was a minus 1. Coefficient of x squared is minus 1. It's cutting it y equals 10 because that's the number at the end of my quadratic function. I've got x minus x squared plus 3x plus 10. I can read off my turning point. My turning point is going to be x equals 1.5, x equals 3 over 2. And that point has the value 3 over 2 and 49 over 4. So the maximum value of this function is 49 over 4. So take time to copy that down properly, have a think about it. Remember, if you want to, go to the last line, minus x minus 3 over 2 squared plus 49 over 4. Square all that out, rearrange it, and see if you can get back up to it looking like 10 plus 3x minus x squared. Right, it's time to try some on your own. So I want you to write in the form y equals ax plus 2 squared plus q and state the coordinates and nature of the turning points. Show off and do a little sketch as well, it would be good. So I've got 3 points for you. So here's some key points to help you along the way. So remember the key steps. I'm going to write it in the form ax squared plus bx plus c. Take out a common factor if there is one. Replace the x squared plus bx and compensate for the extra constant term. Gather together the constant terms. Right, see how you get on, put me on pause and come back in a little while and I'll reveal the answers. Right, hope you're ready. Let's look at the answers. So number 1, y equals 2x squared plus 8x plus 15 has a minimum turning point at minus 27. And that's what it should look like. Question 2, y equals x squared plus 3x minus 4 is at a minimum turning point again at minus 3 over 2 minus 25 over 4. That was a nasty one. Right, well done if you managed to get that one. And that's what it'll look like. And last one, y equals 4x squared minus 12x plus 7 is a minimum turning point again at 3 over 2 minus 2. And there's your function. Now for these examples I've just looked at minimum turning points. We'll do maximum turning points in class because they're a little bit more tricky. So well done if you managed to get all those ones right. They were really, really tricky, and it's time to your progress. So red, amber and green, how are you feeling about this work? Is it National 5 letting you down? Or is it this new higher level work that's really putting your head in a little bit of a spin? If you want extra work, try page 152, exercise 8D, questions 1 and 2. And always remember to ask for help when you're in class, hands straight up if you didn't like the video. Right, so what did you learn today from the video? Well, we learned how to complete the square, which is really useful to sketch a curve with no real roots. And we followed the steps. Write in the form ax squared plus bx plus c. Take out a common factor of a. Replace the x squared plus bx and compensate for the extra constant term. And gather together the constant terms. Right, so this is where algebra skills are really going to come into play. Right, thank you. I'll see you in class.